As Anthony DJ Anglio once famously said, develop a passion for learning, and if you do, you'll never cease to grow. So, today in this session on Kubernetes Interview Questions, I'll be talking about the top Kubernetes related questions asked in your interviews. So, hello everyone, this is Sahiti on behalf of Edureka, and I'll be walking you through this session. Alright, so now before I start with the session, let me give you a brief about the market share on Kubernetes. So, starting with the stats on Kubernetes, the expected overall market for containers in 2020 is around 2.7 billion, and that's around 3.5 times greater than the market in 2016. Not only this, but 60% of the respondents reportedly use containers in their productions. The Kubernetes Cleanator project measures a project's popularity on GitHub around 6,500. That currently places Kubernetes fourth among all the GitHub repositories, and the score is derived from a weighted formula that includes the number of authors, commits, pull requests, and issues. The number of comments on the Kubernetes repository on the GitHub during the past year are around 3 lakhs, and this makes it the most discussed repository by a wide margin. The number of stars on the Kubernetes repository has also received around 28,000, and that's a huge number. So the number of reviews also on the Kubernetes repository has received on the GitHub is around 680, and this makes it the second most reviewed project during the last year. So guys, that were some few stats related to Kubernetes, and this obviously gives you the reason to learn Kubernetes. So now not only these stats, but huge multinational companies such as Hawaii, Pokemon, eBay, Box, Inc., Yahoo Japan, SAP, the New York Times, OpenAI, SoundCloud, and many other companies use Kubernetes to prosper in the scaling industry. So guys, that was a brief about the market share on Kubernetes. Now, let's get started with the interview questions. So for your ease of understanding, I've divided this session into 4 sections. First, I'll start the session with the basic questions asked, and then I'll be concentrating on the questions related to the architecture. After that, I'll be discussing few scenario-based questions, and then finally, I'll end this session with the multiple choice questions. Alright, so guys, let's get started with the basic interview questions. Now, the most basic question that is asked is, what do you understand by Kubernetes? Well, Kubernetes is an open source container management orchestration tool, and its container management responsibilities include container deployment, scaling and descaling of containers, and also load balancing. Let me also tell you that Kubernetes is not a containerization platform, but it is a multi-container management solution. So by multi-container management solution, I mean that it can basically automate your container deployment continuously by scaling and descaling your containers. The benefit with this is that this works brilliantly with all the cloud windows, with all your public cloud vendors or your hybrid cloud vendors, and it also works on the NFS. Now, if I have to give you more information about Kubernetes, then let me tell you that this is a Google developed product. So it's basically a brainchild of Google, and that's pretty much the end of story for every other competitor out there, isn't it? That's because of the community that Google brings with it, right? So Kubernetes is also written in the Go programming language, and now Google has contributed this whole Kubernetes project to the CNCF, which is nothing but the Cloud Native Computing Foundation. So that's the basic information that you can give about Kubernetes when you're asked this question. Now, moving on to the next question, that is, how is Kubernetes related to Docker? Now, as we all know that Docker provides the lifecycle management of containers, and a Docker image defines a built-in representation of the runtime containers. So there are commands to start, stop, restart, link, and also perform other lifecycle methods on these containers. But how do you think these individual containers get linked? How do you think these containers communicate within each other? So that's why Kubernetes. So container running on multiple hosts can be manually linked and orchestrated using Kubernetes. So that's how Kubernetes is related to Docker. Docker offers you a platform for building container services, and these containers can then communicate and orchestrate with each other with the help of Kubernetes. Now, the next question that you can be asked is to tell the difference between deploying applications on hosts and containers. So, when you're asked this question, you can explain with the help of a diagram. So, as you can see on the screen, the left side is the architecture which was used to deploy applications before. So you will have an operating system, and the operating system will have a kernel, and then you will have various libraries installed on your operating system like your Java or your Python or your various other libraries which you need for your application to run, and then you will also have the application installed on top of this operating system. So You can have n number of applications, and all the applications will share the libraries present in that particular operating system. But with deploying the applications in containers, the architecture is a little bit different. So your operating system will have a kernel, and that is the only thing that's going to be common between all the applications. So if there's a particular application that needs Java, then that particular application will get the access to Java. And then if there's any other application which needs Python, then only that particular application will have the access to Python. So these blocks are basically containerized, and these are isolated from all the other applications. So application 1 here on the right side cannot access the libraries of application number 2 and vice versa. So the application and its necessary libraries and binaries are isolated from the rest of the system so as to ensure that this environment is constant and it is not being encroached by any other application, right? So guys, that was the difference that you can tell when you're asked this question about deploying applications on the host and deploying them in the containers. You just have to give examples and talk about libraries. Now, moving on to the next question, that is, what is container orchestration? Now, you can explain this question with the help of microservices. So suppose there's an application with 5 to 6 microservices. Each microservice is obviously put in a container, and these individual services have to communicate with each other. As the word container orchestration is derived from the era of music orchestration, where the word music orchestration meant the amalgamation of all the instruments playing together in harmony. In the same way, you can explain container orchestration by putting all the services in individual containers working together to fulfill the needs of a single server. So all these containers having various services have to fulfill their individual tasks and also have to communicate with each other to satisfy the actions required by the single server. So that's what you mean by container orchestration. You just have to talk about, communication between the containers. Then, moving on to the next question. Obviously, the next question is, why do we need container orchestration? So now, as I was telling you about microservices, when you have 10 to 15 services for a single application, all these services are put into single containers and they have to communicate. So how will they communicate with each other? So the communication between the containers to perform the required actions and complete the task brings the need of container orchestration. Not only this, but there were also few challenges before container orchestration came into place, such as when multiple services were running inside the containers, it increased the human cost of running services. It also increased the size of billings from public cloud providers. Not only this, but it also increased the complexity of running something new into the productions. The scaling obviously became difficult. Setting up new services was manually done, and because of this, manual work was done if any node was crashed. So to avoid these challenges, container orchestration came into place where everything was done automatically. Scaling became much easier. The complexity also reduced to put something new into the production. The cost and size of the services decreased, and also you did not have to set up services manually. It is automatically done. So this brings the need of container orchestration. All right. The next question in the list that we have is, how is Kubernetes different from Docker Swarm? Now, this is a very common question that is generally asked. Well, starting with installation and configuration, setting up a cluster with Docker Swarm can be done with the snap of your fingers. Only two commands need to be executed, one at the manager's end and another at the worker's end. After you're done with that, you can straight away commence your deployment. However, with Kubernetes, the setup is nowhere as easy as Swarm. You need to run commands to bring up the cluster, and then to define your environment, then to define your pod network, and then to bring up the dashboard, and then finally the cluster would be hosted. In terms of scalability, scaling up the number of containers is an eventual need for any company, right? There's no exception there. And here, both Kubernetes and Swarm hold a firm stand. That's because Kubernetes is slightly better at maintaining the cluster strength, whereas Swarm is slightly faster at scaling up. So it's around 5 times faster than Kubernetes. Now, my take on point is cluster strength is more important than anything, right? So in productions, I would rather ensure more stability than agility in scaling, and hence, according to me, I would say that Kubernetes is a winner here. Next, in terms of auto scaling, the clear winner over here is Kubernetes. That's because Kubernetes are intelligent enough to analyze your server load and scale up or scale down as per the requirement. So there's no need for any manual intervention, and this is a big help because the famous traffic catastrophe can be completely avoided. But over here, Docker Swarm is not the confident defender. because when the traffic pours in, it crumbles with no help available. And obviously, because of that, manual intervention is the only way out, and hence it shows no support for auto scaling. Now, if you talk in terms of load balancing, Kubernetes is beaten here. That's because you need to manually configure your load balancing settings. So multiple containers are served as one pod, and each service can be defined as group of pods. Now, the challenge is to get these pods to talk to each other, as they should be easily discoverable. Since the services are used for discovery and not their IP addresses, this proclaims the challenge over here. But if you consider load balancing in Swarm, it's pretty simple. That's because Swarm does auto load balancing. As there is no concept of pods, and hence all the containers discover each other with network IP addresses, which happens automatically as long as the nodes are connected to the cluster. Now, the next difference that you can talk about is rolling updates and rollbacks. So Kubernetes wins the game here again. In fact, both Kubernetes and Swarm clusters support the concept of rolling updates to the containers. Kubernetes performs rolling updates to the pod as a whole, while Swarm does it to the containers straight away. So rolling updates is basically the process of progressively and gradually deploying the updates to the existing apps in all the containers. But as I said, Swarm is beaten here. That's because it does not automatically roll back. So whenever something goes wrong while deploying your updates, both Kubernetes and Swarm provide an option to roll back to the previous stable deployment. But only Kubernetes does auto roll back in case of a failure condition, and the master of the cluster closely monitors the updates and deployments. Now, if you talk in terms of data volumes, Kubernetes allows us to share storage volumes between multiple containers inside the same pod. However, Docker Swarm allows us to share the storage volumes with any other container. But the advantage with Kubernetes is that the storage can be easily mounted on local storage, or either on public clouds like AWS or GCP, or even on the shared networks like NFS. Now, the final difference between Docker Swarm and Kubernetes is in terms of logging and monitoring. So Kubernetes provides inbuilt tools for logging and monitoring. Logging helps in quickly analyzing the logs and understanding where the problem lies in case of a failure. And monitoring helps the master to constantly be aware of the health status of nodes and the services containerized by them. So Kubernetes does inbuilt logging and monitoring. However, with Swarm, you have to use third-party tools like ELK Stack. So these were the differences on Kubernetes and Docker Swarm that you could talk about. Now moving on to the next question, that is, what are the features of Kubernetes? So Kubernetes packages your application, and it automatically places the containers based on these requirements and the resources that are available. Next, in terms of service discovery and load balancing, there is no need to worry. I mean, if you know that you're going to use Kubernetes, then you don't have to worry about networking and communication, because Kubernetes will just automatically assign containers their own IP addresses and probably a single DNS name for a set of containers which are performing a logical operation. And of course, there will be load balancing across them. So you don't have to worry about all these things. The next feature that I can talk about is the ease of storage orchestration with Kubernetes. By this, I mean that you can automatically mount your storage system for your choice. You can choose that to be either a local storage or maybe a public cloud provider such as GCP or AWS, or even a network storage system such as NFS or any other. So Kubernetes also offers to be self-healing. So whenever Kubernetes realizes that one of your containers has failed, it will restart the container on its own. So we basically create a new container in place of this crashed one, and in case your node itself fails, then what Kubernetes would do is that in case whatever containers were running on that node, all those failed containers would restart on a different node. So Kubernetes also offers batch executions. So when we talk about batch execution, you can say that it can manage your batch and CI workloads, which is more of a DevOps role. So as part of your CI workloads, Kubernetes can replace your containers which fail, and it can restart and restore from the original state. So Kubernetes also offers secret of ease in management. So you can deploy and update your secrets and application configurations without having to rebuild your entire image, and without also having to expose your secrets in your stack configuration. So if you want to deploy anything in your secrets, then it can be done. And this will not be available to any other tools. So in short, Kubernetes does that, and you do not have to restart everything and rebuild your entire container, since we also have a feature known as horizontal scaling. So by which you can scale your applications up and down easily with a simple command, and the simple command can be run on the CLI, or you can easily do it by using the GUI, which is your dashboard. And finally, I would also say that Kubernetes also offers the automatic rollbacks and rollouts. So whenever there's an update to your application which you want to release, Kubernetes progressively rolls out these changes and updates to the application or its configurations. By this, ensuring that one instance after the other is sent with these updates, and it makes sure that not all the instances are updated at the same time. So this ensures high availability, and even if something goes wrong with Kubernetes, then it can roll back to that particular change to enable all those things. So in short, if you have to talk about Kubernetes features, then it offers automated scheduling, it offers self-healing capabilities, it offers automated rollbacks and rollouts, and it also offers horizontal scaling and load balancing. So guys, that were the features of Kubernetes. Now moving on with the next question, that is, how does Kubernetes simplify containerized deployment? So a typical application would have a cluster of containers across multiple hosts. For example, your web tier might run on a set of containers. Similarly, your application tier would run on a different set of containers. So the web tier would need to delegate the request to the application tier, isn't it? So in some cases, or at least to begin with, you can say that you may have your web and application server packaged together in the same set of containers, and the database tier would generally run on a separate container. So these two containers would need to talk to each other, and Kubernetes is the solution for this. So Kubernetes offers features so that they can talk to each other, they can orchestrate and also be monitored if something goes down, right? So Kubernetes does all that for the user after the application state has been defined, and this allows it to run on the public, private, or hybrid clouds. So that's how Kubernetes simplifies containerized deployments. It just puts two, three services in containers, and then it helps them to communicate within each other. Now moving on to the next question, that is, what do you know about clusters in Kubernetes? Now, it's a known fact that the basic fundamental between Kubernetes is that we can enforce what's called as desired state management. And really what that means is that I'm going to feed the cluster services a specific configuration, and then it will be up to the cluster services to go out and run that configuration in the infrastructure. So now in the complete system, we have an API which sits in front of the services and the worker nodes, which are basically the container host. And each worker node has a kubelet process that runs, which is basically responsible for communicating with the Kubernetes cluster services. Now, this whole thing, the cluster services, the worker themselves, and the whole setup is what that makes a Kubernetes cluster. Now, if you have to explain with an example, you can consider this. So you can have a deployment file which has all the configuration that is required to be fed into the cluster services. The file that I'm talking about basically has two pods, with the first pod having two container images and three replicas, and the second pod having one container image and two replicas. Now, what happens is I'll take this deployment file, I'll feed it to the API, and then it will be up to the cluster services to figure out how to schedule these pods in the environment, so to make sure that we have right number of pods running. So suppose the cluster services decides on two pods and two replicas on the first worker node, one pod, one replica on the second worker node, and two pods and their respective replicas on the third worker node. So this is the complete responsibility of the cluster services to make sure that the configuration is running across all of the containers and the worker nodes, and this explains the working of clusters and Kubernetes. Now let's move on to the next question, that is, what is Google Container Engine? So Google Container Engine is a management and an orchestration system for Docker container and container clusters that run within Google's public cloud services. So Google Container Engine is an open source container management system which is completely based on Kubernetes. So since you know about Google Container Engine, the next question that you may be asked is, what is a hipster? Now, hipster is a cluster-wide aggregator of a data provided by Cubelet running on each node. It is supported natively on Kubernetes cluster and runs as a pod just like any other pod in Kubernetes cluster. So it basically discovers all the nodes in the cluster and queries usage information from the Kubernetes nodes in the cluster via on-machine Kubernetes agent. So if you have to just define it in a single sentence, then Hipster supports Kubernetes natively on all the setups and is a cluster-wide aggregator of monitoring and event data. Moving on to the next question, that is, what is MiniCube? MiniCube runs on a single node Kubernetes cluster inside a virtual machine on your laptop for all those users who are trying to look out Kubernetes within a day, right? So MiniCube is basically a tool which makes it easy to run Kubernetes locally. So similarly, you may be also asked about what is kubectl. So kubectl is an interface, or you can say it's a platform by which you can pass the commands to the cluster. So it provides the command line interface to run commands against the Kubernetes cluster. Not only this, but kubectl command line tool supports different ways to create and manage Kubernetes components. So guys, that was about kubectl. Now, a simple question that you may be asked is, what is Cubelet? So Cubelet is an agent service which runs on each node and enables slave to communication with master. So Cubelet works on pod specifications that are provided to it, and these pod specifications contain the description of containers. Not only this, but Cubelet ensures that the containers described in the pod specifications are healthy and running, and it only manages the containers that are created by the Kubernetes master to which it belongs. So that was about Kubelet. So if you just have to answer in simple terms, we all know that the basic unit of Kubernetes is pod, right? And Kubelet is a process that runs all the pods present in that particular cluster. Okay. So now let's move on to the final question of this section. That is, what do you understand by a node in Kubernetes? So, a node is a worker machine in Kubernetes which was previously known as a Minion. So, a node may be a virtual machine or a physical machine depending on the cluster. Now, each node has the services necessary to run pods and is managed by the master components. The services on a node include containers, which are mainly the Docker containers, Kubelet, Queue Proxy, and also the kubectl to run the commands and set up the nodes. So guys, these were the components of nodes that you can talk about. Now, obviously, you can elaborate about these components one by one. All right, guys. So these were some basic questions on Kubernetes. Now, let's move on to the architecture-based questions. So starting with the first question, which is, what are the different components of Kubernetes architecture? So it mainly has two components, that is the master node and the worker node. Now, this master and worker node have various components, like the master has the Kube Controller Manager, the Kube API Server, the etcd, and Kube Scheduler. And similarly, the worker node has the Kubelet processes and the Queue Proxy. Now, each one of them have their own functionalities and are responsible for different actions. So these were the components of Kubernetes architecture. Not only this, but this complete master node can be connected to a cloud environment, which can be either a public cloud environment or a private cloud environment. Now, the next question that we have is, what do you mean by Queue Proxy? So Queue Proxy runs on each node. It can do simple TCP UDP packet forwarding across the backend network services, and it is basically a network proxy which reflects the services as configured in Kubernetes API on each node. So these Docker link compatible environment variables provide the cluster IPs and ports which are opened by proxies. So that is the working of Queue Proxy. It is mainly used for network services and packet forwarding. Now, moving on to the next question, that is, can you brief about the working of master node? So, as it is a known fact that Kubernetes master controls your nodes, and inside nodes you have containers. Now, these containers are not just contained inside them, but they're actually contained inside the pods. So you have nodes, and then there are pods, and then inside each pods there will be number of containers depending upon your configuration and your requirements. Now, when a user sends a request from the user interface or the command line interface, the API gateway takes in that request and passes it on to the master node. So the master node has mainly three components, that is the API server, controller manager, and the scheduler. Not only this, but it also has etcd. So the API server exposes all the APIs which are responsible for establishing communication between the Kubernetes node and Kubernetes master components. Then comes the controller manager. So the controller manager is basically a compilation of multiple controller processes running on the master node, and this is nothing but the controller manager. So each controller has its own responsibility and communicates with the API server to manage the endpoints. And also talking about the Kube scheduler. Kube scheduler is basically responsible for distribution and management of workload on the worker nodes. So it selects the most suitable node to run the unscheduled pod based on the resource requirement and keeps a track of resource utilization. So as soon as the master node sends a request to allocate the pod, the scheduler sees where it has to schedule the pod, and then it sends back the request to the API server, and then the API server schedules the pod onto the respective node. Now talking about etcd, etcd is basically like a database which stores the key value store used for configuration management, service discovery, and also coordinating distributed work. Not only this, but let me tell you that the replication controller ensures that the request and the number of pods are always running on the nodes right. So that's how Kubernetes master works. Now, the next question that you can be asked is, what is the role of Kube API server and Kube scheduler in the master node? So starting with the API server, it is the front end of the master node. So it exposes all the APIs of Kubernetes master node components and is responsible for establishing communication between the Kubernetes node and the Kubernetes master components. So it follows the scale out architecture, that is, it can expand horizontally by adding more and more instances. Whereas when we talk about Kube Scheduler is responsible for distribution and management of workloads on the worker nodes. So it selects the most suitable node to run the unscheduled pod based on the resource requirement and keeps a track of resource utilization and makes sure that the workload is not scheduled on the nodes which are already full. So that was about Kube Scheduler and Kube API Server, guys. Kube Scheduler is basically responsible for distribution and management of workloads, and Kube API Server validates and configures data for API objects such as pods and services. Now, the next question that you can be asked is, what do you know about Kubernetes Controller Manager? So the answer you can give to that is that there are multiple controller processes running on the master node, but all of them are compiled together to run as a single process, which is the Kubernetes Controller Manager. So each controller has its own responsibilities and communicates with the API servers to manage the endpoints. The controller manager is a daemon that embeds controllers and does namespace creation and garbage collection. So the different types of controller managers running on the master node are node controller, replication controller, service account and token controllers, and endpoint controllers. Now, node controllers manage the status of the nodes. By managing the status of nodes, I mean the creation, updation, and deletion of nodes. The replication controller maintains the number of pods for every replication object in the system. The service accounts and token controllers create default accounts and API access tokens for the new namespaces. And finally, the endpoint controllers take care of the endpoint objects like the pods, joint services, etc. So that was about the cloud controller managers. Now, what exactly is etcd? Well, etcd is a distributed consistent key value store used for configuration management, service discovery, and coordinating distributed work. So when it comes to Kubernetes, etcd reliably stores the configuration data of the Kubernetes cluster, representing the state of the cluster, that is, what nodes exist in the cluster, what pods should be running, which nodes are they running on, and a whole lot more. And this information is stored at any given point of time. So as all the cluster data is stored in etcd, you should always have a backup plan for it. So you can easily back up your etcd data using the etcd control snapshot save command. And in case you're running Kubernetes on AWS, you can also back up etcd by taking the snapshot of EBS volume. Also, let me tell you that etcd is written in the Go programming language and uses the raft consensus algorithm to manage a highly available replicated log. Now, the next question is, what are the different types of services used? Well, the answer to this question is there are four different types of services used. That is the cluster IP, node port, load balancer, and external name. So the cluster IP exposes the services on cluster internal IP. This is the default service type, and by choosing this value, it makes that the service can be only reachable from within the cluster. So that means you cannot reach the service out of the cluster. Now the second type is node port. So node port exposes the services on each node's IP at a static port, that is a node port. So a cluster IP to which the node port service will route is automatically created, and you'll be also able to contact the node port service from outside the cluster. Next, we have the load balancer. So the load balancer exposes the services externally by using a cloud provider's load balancer. The node port and the cluster services to which the external load balancer will route are automatically created. And finally, we have the external name. So the external name maps the service to the contents of the external name field by returning a CNAME record with its value. So there is no kind of proxying involved in this kind of setup, and this requires a 1.7 or a higher version of kubedns. So to name, there are four different types of services used, that is the cluster IP, node port, load balancer, and external name. Now, how do you think that you can achieve load balancing in Kubernetes? So basically, a load balancer is one of the most common and standard way to expose your service. So you can have an external load balancer or an internal load balancer depending on your working environment. Now, in the case of the internal load balancer, it will automatically load balance and allot the pods with the configurations required. Alright guys, so that's how you can achieve load balancing in Kubernetes. Now, next in the list, we have the question, what is Ingress network and how does it work? So, well, Ingress network is a collection of rules that allow inbound connections which can be configured to give services externally through reachable URLs, load balancing traffic, or by offering name-based virtual hosting. So, Ingress is the most powerful way of exposing services. The services and pods have IPs only routable within the cluster. It also acts like an entry point to the Kubernetes cluster. Not only this, but Ingress is an API object that manages external access to the services in a cluster, usually by HTTP request, and it sits in front of multiple services and acts as a smart router. Now, if you have to explain the working of Ingress network, explain it with an example. So consider two nodes having the pod network, the root network namespaces, and the Linux bridge. In addition to this, also consider the network plugin Flannel added to the root networks. Now, if you want the packet to flow from pod 1 to pod 4, the packet leaves pod 1 network at Ethernet 0 and enters the root network at virtual Ethernet 0. Then, it is passed on to the Linux bridge, which makes the ARP request to find the destination. And when it finds out that nobody on this node has the destination IP address, the bridge sends the packet to the Flannel 0 as the node's route table is configured with Flannel 0. Now, the Flannel daemon talks to the API server of Kubernetes to know all the pod IPs and their respective nodes to create mappings for pod IPs to the node IPs. The network plugin wraps this packet in a UDP packet with the extra headers, changing the source and the destination IPs to their respective nodes, and sends this packet out via Ethernet 0. Now, since the route table already knows how to route the traffic between the nodes, it sends the packet to the destination node 2. The packet arrives at Ethernet 0 of node 2 and goes back to the Flannel 0 to decapsulate and emit it back into the root network namespace. Again, the packet is forwarded to the Linux bridge to make an ARP request to find out that IP belongs to the virtual Ethernet 1. So the packet finally crosses the root network and reaches the destination pod 4. So if you have to talk about Ingress networks, then remember that Ingress network is all about routing. Now, moving on to the next question, that is, what do you understand by Cloud Controller Manager? Well, the Cloud Controller Manager manages the communication with the underlying cloud services. It might be split out into several different containers depending on which cloud platform you're running on. So, the Cloud Controller Manager is responsible for persistent storage and network routing and helps abstracting the cloud specific code from the core Kubernetes specific code. It enables cloud vendors and Kubernetes code to be developed without any interdependency. So your cloud blocks the respective controllers depending upon the use case, and the cloud vendor develops their code and connects with the Kubernetes Cloud Manager while running the Kubernetes. So there are mainly four types of cloud controller managers, that is node controller, route controller, volume controller, and service controller. So the node controller checks and confirms that the node is deleted properly after it has been stopped. The route controller manages the traffic routes in the underlying cloud infrastructure. The volume controller manages the storage volume and interacts with the cloud provider to orchestrate volume. And finally, the service controller is responsible for the management of cloud provider load balancers. So guys, that was about cloud controller managers. Now moving on with the next question, that is, what do you understand by container resource monitoring? Well, monitoring of Kubernetes cluster environment is much different from the regular client service architecture. So Kubernetes factors the management of cluster by creating abstraction at different levels like containers, pods, services, and the whole cluster. So for users, it becomes very important to understand the performance of application and resource utilization at all different abstraction layers. So this approach is very important for the large clusters and distributed resources. Now there are various tools for container resource monitoring. Starting with Grafana. Grafana is a time series database and stores all the data captured by the hipster pods. The hipster tool gathers the data and events from the containers and pods within the cluster. The C Advisor is a built-in tool in Cubelet that automatically discovers all the active containers and monitors their performance and resource usage. The InfluxDB is used along with the Hipster for visualizing data within your Kubernetes environment. And finally, the Prometheus is a project of Cloud Native Computing Foundation which provides powerful querying, alerting, and visualizing capabilities. So, guys, that was about container resource monitoring. Now, the next question that you can be asked is to tell the difference between the replica set and the replication controller. Well, it's a known fact that both the replication controller and replica set almost provide the same functionalities. The replication controller helps to achieve the desired state by making sure that the desired number of pods always exist. So if a pod crashes, the replication controller creates a new one. It updates and deletes the multiple pods with a single command and helps to create, scale, and maintain multiple pods as part of the desired state. Now coming to the replica set is almost same as the replication controller. It also ensures that the specified number of pod replicas are running at any given time. The main difference comes from the support of selectors. The replica set supports the set based selectors, whereas the replication controller supports only the equity based selectors. So the set based selectors is where you can define a proper set. So suppose you have an application in an Nginx, NPS or hello. So here, if the application is equal to any of your Nginx, NPS or hello, the selector will take it as a true result. But equity based matches the same exact word or phrase that is mentioned. So for example, if the label says app is equal to Nginx, it will only look for the pods which have the label app equal to Nginx and nothing else. So that's the basic difference between replica set and replication controller. Replica set uses the set based selectors and replication controller uses the equity based selectors. Now, moving on to the next question, that is, what do you understand by a headless service? Headless services are very important for stateful applications. The definition of headless service is similar to that of a normal service, but the only difference is that it does not have the cluster IP. Now, the biggest benefit of headless service is that you can directly reach the respective pod. Otherwise, you first have to go to the load balancer and then you have to access it through some proxy. So headless service is the same as the normal service, but yes, the only difference is that it does not have a cluster IP. So when you don't want load balancing or a single cluster IP, you use headless services. Now you may think, why do we use it, right? Basically, this is used to reduce the coupling to the Kubernetes system. Now, moving on to the next question, that is, what are the best security measures that you can take while using Kubernetes? Well, there are n number of security measures that you can take while using Kubernetes that may differ according to your applications and according to the environment that you're using. But some of the basic measures are apply security updates to environment regularly. You should restrict the access to the etcd. You should log everything on the production environment so you know what is happening and when that's happening. You should implement network segmentation. You should also define strict policy or rules for the resources so that resources are optimally used. You should implement continuous security and vulnerability scannings. You should enable the auditing part. You should also provide limited direct access to the Kubernetes nodes so that all of them do not have the access and only limited number of people or limited number of resources have access to the Kubernetes nodes. You should define the resources quota and you should also use images from the authorized repository only. So these were some basic security measures that you can talk about. Well, the security measures always differ from the application and also from the environment. Now, moving on to the final question of this section, that is, what do you understand by federated clusters? Now, federated clusters is something by which you can manage multiple clusters as if they were one. So in other words, you will have the freedom to create multiple Kubernetes cluster within your data center or in your cloud, and you can use federation to control or manage them at one place. Now, this is only achieved by doing two things. That is by syncing the resources across clusters and also finding the cross-cluster discovery. So by syncing the resources across clusters, I mean that federation helps to keep the resource synced across multiple clusters. So this can be used to deploy the same deployment set across multiple clusters. Also, if you talk about cross-cluster discovery, it provides the ability to have the DNS and load balancer with backend from all the participating clusters. So you can have a DNS record to be used to access the multiple clusters available. So that was about federated clusters. Alright guys, so now that you've gone through the basic and the architecture based questions, let's move on to the scenario based questions. So starting with the first question, consider there's a company handling various number of products and as its business expanded rapidly, their monolithic application caused a problem. Now, how do you think they shifted from monolithic architecture to microservices and deployed their containers in Kubernetes? Now, when you're asked such questions, you can say that as the company's goal was to take all the monolithic application and put it within a new platform in new architecture style, that is by Kubernetes and microservices, the company can end up building piece by piece in parallel and just switch the configurations in the background. So using this procedure, the company can migrate without any downtime, and once they migrate once or twice, they can monitor to make sure that everything is running stable, and then the rest of application can be again moved into the Kubernetes cluster. So by applying such method, the company can see immediate impact by cutting monthly costs by a large percentage and also running at the same capacity and scaling horizontally. So with the usage of containers, they can do the migration in few seconds with no cost of extra money. So in such situations, you can just say that, they can build the microservices one by one parallelly and then switch to configurations in the background. Once they're done with that, they can migrate once or twice and monitor their application on Kubernetes cluster. And once they find that it is stable, they can move the complete application into the Kubernetes cluster. So guys, that was an answer to such scenarios. Now, moving on to the next scenario, that is, consider a multinational company with a very much distributed system with various number of data centers and virtual machines and many employees working on various tasks. Now, how do you think such company can manage all the tasks in a consistent way with Kubernetes? Now, it's a known fact that the IT departments need to launch tens and thousands of containers with the tasks running across thousands of nodes across the world. And with a very much distributed system, managing of all the tasks in a more consistent way is always a challenge. Now, for any company using virtual machines to encapsulate these applications, it would obviously take a lot of time, right? So, the company can decide to use Kubernetes orchestration platform that offers them the agility, scale out capabilities, and DevOps practices to the cloud based applications. So the company can therefore customize the scheduling architecture, which makes the company get better affinity between the container tasks, and obviously that gives them much greater efficiency. So such framework can support multiple container formats and also offer extensive support for various container network solutions and container storage. So in such situations where you have a distributed system, the only answer is to just switch from your virtual machines to container platforms and then orchestrate them with the help of the best orchestration tool available, that is Kubernetes. Now, let's consider the next scenario. Now, consider a situation where a company wants to increase its efficiency and speed of its technological operations by maintaining minimal cost. Now, how do you think they will achieve this? Well, the answer to this is the company can try out the DevOps methodology by building a continuous integration and continuous delivery pipeline. Now, once they build the CI/CD pipeline, one problem that may occur here is that the configurations can take time to go up and running. Now, after building the CI/CD pipeline, the company's next step should be to work on the cloud environments so that the company can schedule containers on a cluster and can orchestrate them with the help of Kubernetes on the cloud environment. So, in short, with this approach, the company can definitely reduce their deployment time and also get faster across various environments with the help of cloud. So, in such situations where a company wants to increase its speed and efficiency, then they just have to use the DevOps methodology and come out from the waterfall and the agile methodology to build a CI/CD pipeline and then use the Kubernetes platform to orchestrate the containers and finally use a cloud platform by which they can get faster across various environments. Now let's move on to the next scenario. Now suppose a company wants to revise its deployment methods and wants to build a platform which is much more scalable and responsive. How do you think this company can achieve this to satisfy their customers? In such situations, it's an obvious fact that in order to give millions of clients the digital experience they expect, the company needs a platform that is elastically scalable and also much more responsive so that they could quickly get the data to the client website. Now, to do this, the company should move from their private data centers, if they have, to any cloud environment such as AWS. So, with a new microservice architecture in mind and the freedom to implement what's best for the organization, they should begin by using Docker containers and use the best orchestration platform available, that is Kubernetes. This would give them the basic framework so that the teams can be autonomous in what they are building and deliver very quickly and frequently. So, with a mixture of microservices architecture and Kubernetes platform, the company can definitely get more scalable and much more responsive. So you can think of a shopping website. So that works in this way. All the features on a shopping website are put into microservices, and these individual microservices are put into containers. And these containers then communicate with each other with Kubernetes platform. And finally, they're put on the cloud environment so that they get faster across various environments. All right, guys. Now moving on to the next question. That is, consider a multinational company with a very much distributed system and is looking to solve its monolithic code based problem. How do you think that they can solve their problem? Well, the answer to this question is really simple. They can shift their monolithic code base to microservices architecture, and once they shift into microservices architecture, they can put each service in a Docker container and then they can orchestrate these containers with the help of Kubernetes. Now, let's consider a next scenario. Now, it's a known fact that the shift from monolithic to microservices solves the problem from the development side, but increases the problem at the deployment side. Now, how do you think that the problem can be solved at the deployment side? So the team can experiment with the container orchestration platforms, that is Kubernetes, and can run Kubernetes in its data centers. So with this, the company can generate a templated application and deploy it within minutes and have actual instances containerized running in the staging environment at any given point. So with Kubernetes project, they can have dozens of microservices performing their own tasks, and this obviously improves the resilience and productivity, because even if a node goes down in the production side, then it can be rescheduled immediately and there would be no performance impact. So in that way, the problem at the deployment side can be solved. Now, let's move on to the next scenario. That is, suppose a company wants to optimize the distribution of its workloads by adopting new technologies. How can the company achieve the distribution of resources efficiently? So the answer is none other than Kubernetes. It's a known fact that with the containers concept that the Kubernetes offers, all the resources are optimized efficiently and only those resources are used which are needed by that particular application. So if you have 10 applications, then all those 10 applications would be only using those resources which are needed by that particular application respectively. Any application would not be using any other resource required by any other application. So in this way, all the resources are distributed in a really efficient manner with the help of Kubernetes. Alright, now let's consider another scenario where a carpooling company wants to increase the number of servers by simultaneously scaling their platforms. So how do you think the company will deal with the servers and their installations? So instead of the usual choice of shifting to cloud virtualization or use private cloud or their own servers, the company can adopt the concept of containerization. So once they deploy all their applications into containers, they can use Kubernetes for orchestration and use container monitoring tools like Prometheus to monitor the actions in containers. So with the help of the container monitoring tools and Kubernetes for orchestration, the company can deal with the servers and their installations. So each server will have its own installation and it will be in its own container. Now, with such usage of containers, they can copy a service in a matter of minutes. So this will give them better capacity planning in the data centers because they will now have fewer constraints due to the abstraction between the services and hardware they run on. So now the developers can focus only on the features that they're developing and not on the infrastructure. Now, let's move on to the next scenario. That is, consider a company where the company wants to provide all the required handouts to its customers who are having various environments. Now, how do you think they can achieve this critical target in a really dynamic manner? So, well, the company can use Docker environments to put together a cross-sectional team to build an investor research web application using Kubernetes with the goal of getting it into the production within the shortest time frame. So, with such a machine running, the company can give the handouts to all the customers having various environments, and obviously, this will change the way our developers are starting to think about their future development. Now let's look at the last question for this section. So suppose a company wants to run various workloads on different cloud infrastructures from bare metal to public clouds. How will the company achieve this with the presence of different interfaces? The answer is again Kubernetes, because Kubernetes supports various environments and the company can decompose its infrastructure into microservices and adopt Kubernetes. And this will let the company achieve in what it needs and also run various workloads on different cloud infrastructures, whether it is a public cloud provider or it's a private cloud provider or if it's their own network system. So guys, those were some scenario questions. So now that you've gone through the basic questions, the architecture based questions and the scenario based questions on Kubernetes, let's get into the multiple choice questions. So the first question is, what are the Minion Kubernetes cluster? So the options are, they're a cartoon character, they're a workhorse or a worker node of the cluster, they're a monitoring engine used widely in Kubernetes, or they are Docker container services. So well, the answer to this is they are the worker nodes of the cluster. So when you talk about minions, you should always remember that they're the worker nodes of the cluster. Now moving on to the next question, that is, Kubernetes cluster data is stored in which of the following? Is it Kube API server, or is it Cubelet, or is it etcd, or is it none of the above? So well, the answer to this question is that the cluster data is stored in etcd. As I told you, that etcd is like a database which stores all the key value configurations. Now moving on to the next question, that is, which of them is the Kubernetes controller? Is Replica set a Kubernetes controller? Or is the deployment file a Kubernetes controller? Or is the rolling updates a Kubernetes controller? Or are both Replica set and deployments the Kubernetes controller? Well, the answer to this question is that both the Replica sets and deployments are Kubernetes controllers. Now moving on to the next question, that is, which of the following are core Kubernetes objects? So by core Kubernetes objects, that is on which the complete Kubernetes system relies on. Is it the pods, or is it the services, or is it the volumes, or is it all of the above? Well, the answer to this question is that it is all of the above. All the pods, services, and volumes are considered as the core Kubernetes objects. Now, moving on to the next question. The next question is, the Kubernetes network proxy runs on which node? Is it the master node, or is it the worker node, or is it all of the nodes, or is it none of the above? Well, the answer to this question is that the network proxy runs on each and every node, so the answer is all of the nodes. Now, what are the responsibilities of node controller? Is it to assign a CIDR block to the nodes? Is it to maintain the list of the nodes? Is it to monitor the health of the nodes, or is it all of the above? Well, the answer to this question is that it's all of the above, because the responsibilities of node controller include to assign a CIDR block to the nodes, also include to maintain the list of the nodes, and also include to monitor the health of the nodes. Now moving on to the next question, that is, what are the responsibilities of a replication controller? Well, is it to update or delete multiple pods with a single command, or is it to help to achieve the desired state? Or does the replication controller create a new pod if the existing pod crashes? Or is it all of the above? Well, the answer to this question is that it is all of the above. Since replication controller updates and deletes multiple pods with a single command, it's true that it helps to achieve the desired state, and it obviously creates a new pod if the existing pod crashes. So moving on, we have the next question, that is, how to define a service without a selector. Is it to specify the external name, or is it to specify an endpoint with the IP address and port, or is it just by specifying the IP address, or is it just by specifying the label and API version? Well, the answer to this question is that you can define a service without a selector by specifying the external name. Now moving on with the next question, that is, what did the 1.8 version of Kubernetes introduce? Is it the taints and the tolerations? Is it the cluster level logging? Is it the secrets, or is it the federated clusters? Well, the answer to this question is that the 1.8 version of Kubernetes introduced taints and tolerations. Now, let's move on to the final question of this session, that is, which handler is invoked by the kubelet process to check if a container's IP address is open or not? Is it the HTTP GET action? Is it the exec action? Is it the TCP socket action, or is it none of the above? Well, the answer to this question is that it is the TCP socket action. So guys, that was all about Kubernetes interview questions. I hope that you've enjoyed this session. All the best for your interviews. Thank you and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!